You ever stop and think about what happens in that split second after you type your password and hit enter? It's so much more than just a little green check mark. Turns out there's a whole hidden world of digital locks, secret codes, and a constant, invisible battle between protection and attack. In this explainer, we're going to crack open that world and take a look at the secret life of your password.
And this quote, man, it just hits the nail on the head. Cholta hai is a Hindi phrase, and it basically means it'll do or, anything goes. That casual attitude, that it'll be fine mindset. In cybersecurity, that is the single biggest vulnerability you can have, because one weak link, one moment of Cholta hai can bring the whole system crashing down.
So yeah, that's the big question we're going to dig into. What's going on behind the curtain? It's not magic. It's this fascinating, invisible process designed to keep you safe. But you have to understand, it's an arms race. The methods have had to evolve like crazy just to keep up with the people trying to break in.
All right, let's start with the absolute worst case scenario. Imagine a website stored your password exactly as you typed it, what we call plain text. If they had a single data breach, it would be a complete catastrophe. A hacker would just get a shopping list of usernames and their exact passwords. Game over. This right here is the fundamental problem that all modern security is trying to solve.
So, to get around storing the actual password, systems use this really clever one-way trick called hashing. The best way to think about it is like turning your password into a unique, irreversible digital fingerprint.
Now, the key phrase here is one-way function. It's super easy to go from your password to the hash, but it's practically impossible to go backward, to take that hash and figure out the original password. So the system never actually knows your password. It only stores this complex, jumbled-up digital fingerprint.
And check this out. This is the power of hashing in action. Just by changing one single character, from a lowercase p to a capital P, you get a completely different hash. It's not even close. This is called the avalanche effect. A tiny little change in the input causes this massive, unpredictable change in the output. It's what ensures that even really similar passwords have wildly different fingerprints.
So we're only storing the hash, not the password. It seems like a perfect solution, right? I mean, if a hacker steals the database, all they're getting is a bunch of gibberish. Your password should be safe. But of course, the story doesn't end there. The attackers, they found a clever way around this.
Welcome to the hacker's playbook. See, instead of trying to reverse the irreversible hash, attackers came up with ways to just match it, or in some cases, bypass it altogether. Let's look at two of their most effective tricks.
First up, we've got the rainbow table. Imagine a gigantic dictionary. But instead of words and definitions, it's got millions of common passwords and their pre-calculated hashes right next to them. So if a hacker steals a hash, they don't have to crack it. They just look it up in their rainbow table to find the password that matches. It's basically a brute force attack on an industrial scale.
And this is where things get really sneaky. What if an attacker could use a stolen hash directly, without ever even needing to know what your original password was? Well, that's called a pass-the-hash attack. In certain systems, the authentication process actually uses the hash itself as a kind of key or a token. So an attacker can steal your hash from one computer and just present it or pass it to another server to log in as you. They're not cracking anything. They're just using your digital fingerprint like it's their own.
So clearly, simple hashing just wasn't going to cut it anymore. The good guys had to step up their game. In response, cybersecurity experts developed a whole new generation of defenses. It was time to build a much stronger vault for our passwords.
The first and maybe most critical defense is called salting. Here's how it works. Before hashing your password, the system adds a unique, random string of characters, the salt. So now, if two people have the exact same password, say password 123, their salted hashes will be completely different. And just like that, rainbow tables become useless. An attacker would need a separate, massive table for every single possible salt, which is just computationally impossible.
The next defense is called key stretching. And the idea is so simple, but honestly, it's brilliant. You make the hashing process slow on purpose. The algorithm doesn't just run the calculation once. It runs it thousands, maybe even hundreds of thousands of times. For you, when you log in, it's a completely unnoticeable delay. But for an attacker trying to guess billions of passwords a second, it's like hitting a brick wall at full speed.
And all this brings us to the modern champions of password hashing. You've got algorithms like bcrypt, Script, and Argon 2. They all combine salting with some serious key stretching. Script takes it a step further. It's not just slow, it's also memory intensive, which is a huge pain for attackers using powerful graphics cards. And then there's Argon 2, which actually won the official password hashing competition. It's pretty much the current state of the art.
But here's the thing. All of this incredible technology, all these complex, brilliant algorithms, they can be defeated by one simple thing: human error. The final, and honestly the most important firewall is always you. Security isn't just about software. It's about behavior, it's about discipline.
So what can you actually do? It's pretty simple. Use a password manager so you can have strong, unique passwords for every single site, no more reusing. Always enable two-factor authentication whenever it's an option. And the simple habits, like locking your computer when you walk away, or being a little skeptical of weird emails, those are your strongest defenses. They're totally non-negotiable in today's world.
I just love this quote because it's so blunt and so true. All the mind-bendingly complex digital security in the world means absolutely nothing if the password is just written down on a sticky note and stuck to the monitor. That's not protection. That's an advertisement, an open invitation.
And really, that's the bottom line. We've seen this incredible journey your password takes, from plain text to salted, stretched, cutting-edge hashes. But you have to remember, the most advanced digital lock in the world is completely useless if you leave the key right under the doormat. So, the question I want to leave you with is this: where are you leaving your keys?